Assalamu alaikum, good afternoon students of 741. Hope you're doing well. Hope you are staying safe, staying healthy in these times. So hopefully you remember completing from the last video your week 4 content. We looked at conservation of momentum, how the total momentum before in any system is equal to the total momentum after of the two objects which have a hitting each other contact, like a collision. We call it collision. So when two things hit, with this and this, it's a collision. Alright, now let's look at today what we're going to look at week 5 content. In this video we'll explain to you how to help to complete this workbook. So we've done all of this. This is week 4 still. We looked at this equation. We said all the momentums before the collision equals all the momentums after the collision. So we looked at the two balls before, the mass and the velocity, the mass and the velocity, and the two balls after, the mass and the velocity, and the mass and velocity of the two balls after, and we added them. And we said if it's elastic collision, they will be the same before and after. And we solved some problems. We solved this problem with the cart. Then you had to go at solving this one yourself. Here we go, so week 5. This video will take you all the way down to the assessment, which we'll do in week 6. So this is the stuff you've been working on this week. If you struggled with this, just follow through this video. This is just more application, this pop quiz of the equation we had above. So it tells you the mass and the velocity before. This is before, right? Playing pool. The white ball is moving, the black ball is not. And then afterwards, the white ball is not moving and the black ball is moving. So this, in this example, the white ball is perfectly still. It's not clear, but this is the idea. So let's look at the mass and the velocity before the collision. We're going to have, I'll just make my text bigger. I can't read it that well, but it's 0.25 is the mass times the velocity, which is 2. Add the mass and the velocity of this one, 0.25 again, so they're the same mass, times 0, because there is no speed. This one is not moving yet, and will equal the mass and the velocity of this one plus the mass and the velocity of this one. So the same mass, right? Mass, but no velocity for the white anymore. And the black ball here, we're trying to find the velocity of the black ball, so we don't know that. We know the mass though, the mass is the same, 0.25 times the velocity for the black ball. So you're going to just solve all of this, simplify this one to make a number, simplify this one to make a number, simplify this one to make a number, and simplify this one. So you just break it down. It looks complicated now, but it's not after you just say, okay, what's 2 times 0.5? Let's put it here. What's 0.25 times here? Put it here. What's this times this? Put it here. And this one we can't do because we don't know v, but we can still write 0.25 v. So 2 times 0.25, put your answer here. We need to add. The add signs are still there, so the equal signs, very important. And then just where I have put the line, put your answer from the calculator. So remember, these are the mass times the velocity of before and after. Here's the before, here's the after. which we can't do, is this, so it stays the same. It's just 0.25 V. So you're gonna keep simplifying this until you find V. This is times 0, so it's like it's not there. This is times 0, so it's like it's not there. So you're just gonna end up with, what's 2 times 0.25? Do it on your calculator. 0.5. I crossed them out because it's like it's not there, it's just a 0. If you do that in the calculator, so 0.5 plus 0, 0.5. You can see how we can follow through. I'm just giving you the example to remind you because we're doing a similar thing today. I don't need the naught, right? It's just doing naught plus something. It's just the something. If I do this plus nothing, I just have this. So naught plus this equals this. So 0.5 equals a half V, or a quarter V, sorry, 0.25 V. So rearrange it for V. You know from your maths that if you have multiply here, you have to put it to divide. So it's 0.5 divided by 0.25. Remember, this dash just means taksim, yeah? Equals V. And don't forget your units for V, meters per second. So we solved it. Just put this in your calculator to show you're working. Maybe you don't need to put the crosses over these lines. It's just to show you that there's no point. If something has no velocity, it has no momentum, right? The total momentums before added together equals the total momentums after. You can solve it for V. This is the last step, the tricky step, because when we move something timesing on this side, this is 0.25 times V, and it goes to divide on the other side. This is maths rearranging. So today we're looking at the other type of collision, which is what happens when two masses, instead of bouncing off each other after collision, they stick to each other. So before we said that the two things are bouncing off each other when they hit, that's the elastic. But this time what's going to happen is they will connect and then move. I'll zoom out a second so you can see. So a good example is if I'm playing American football and here's my player and here's my player and he's running into him, he tackles him and they both fall to the ground together. So they will both move in the same mass. They become one mass. This is an inelastic collision. They both move together after the hitting. Okay, now let's check this out. Here is the example, right? So this one's not moving, this one is moving. They hit each other, they link together, and then they move as one. They move as one mass in the end. Inelastic collision is where the energy is reduced. The kinetic energy goes down. Okay, there's my equation. So it's slightly different. But before we said that all the momentums before equals all the momentums after. This is still true. This is still true, but when one thing has an inelastic collision, we will use this formula instead. So using this formula, let's solve the problem. Imagine a fish eats another fish. Because here's a good example. They will become one mass. The fish will be inside the other fish. So after the collision, the two masses will just be added together and count as one single mass. That's why we only have one really at this side, one momentum. We could call that M3, the new mass of the small fish and the big fish together if we want. So let's do an example. Example we'll do together, question 1. Question 2 you will try yourself, just using that equation. Now it doesn't matter which one you call M1 and M2, it doesn't make any difference. So let's call the big fish M1. So if the big fish is M1, let's look at this equation. It's 8.5 kilogram. So M is 8.5. Just using this, right? And because it's each momentum, just let's separate it with brackets, just to make our calculator make no mistakes. And it says it swims towards 2.5 kilogram fish. Okay, still don't know V1. What's the velocity of the big fish? The large fish swims at 1.2 meters per second. Alright, so we're going to use 1.2 here. You can see how I'm matching it to this equation, but I'm just adding brackets. Plus M2V2. So M2 is the mass of the small fish, 2.5 kilograms it says. Kg, remember, M. If it's M mass, it's kg. And multiplied by the velocity of the small fish. That's the question. What is the velocity? That's not the question. What is the velocity after the launch? So after the collision, it's asking for this V over here. It's different V. This should say V3 really, because it's not the same as this V2. It's the bad equation. Alright, so how fast is this fish moving? Doesn't say, there's no number, right? Consider a big fish, 8.5 kilograms, swims towards the small fish, 2.5 kilograms. We've got M1 and M2. We need to have everything except for this final V. And the small fish is at rest. What does at rest mean? If I'm resting, if I'm sleeping, am I moving? Do I have any speed? Yes or no? I would say no, I'm not moving. So that's going to be 0 speed. So at 0 speed, he's just sleeping. It doesn't look like he's sleeping. I can see his eyes open, but I don't think fish have eyelids. And equals. Now we use the brackets. M1 plus M2. So I know M1 and M2. I know it's 8.5 and 2.5. So I can just say 8.5 plus 2.5 here. Same numbers again. And then there's this V2 here, which just stays multiplied by V2. Remember, if there's nothing in the equation between the letters, it must be a multiply verb. So we can write here V as my unknown. It doesn't have to say V2. Ignore these letters. These numbers are silly, to be honest, especially here. Because these V2s, it's not the same as this V2. It's different. So now we have to try and find V. So we have to do some maths again. Let's break it down. Do 8.5 times 1.2. Put it here. Do 2.5 times 0. Put it here. And do 8.5 plus 2.5 and put it here. Alright? So you'll end up with whatever that answer is, plus whatever the other answer is, equals 8.5 plus 2.5, whatever that is, times V. So then you plus those two numbers together and you do the same method as the final step before. So the final step before, remember, was to put this number to the other side as taksim. We add those two numbers and then we divide this number. Like I said, I'll do this full example with you, but you're going to do this one and try this one yourself. Okay, so 8.5 times 1.2. 8.5 multiply 1.2, I get 10.2 here. 2.5 multiply 0. I don't need a calculator because multiply 0, verb 0, always 0. 8.5 plus 2.5, you can do this in your head, 11. So then 10.2 plus 0 will give me 10.2, right? Plus nothing. And then equals still 11V. So So I didn't find V, I found 11V, but I only want one V, I only want V. So I have to put this 11 to the other side as Taksim. Now there's no space for me to do it, so I'll do it here. The last step is 10.2 over 11 equals V. You can find your answer for V, whatever this is. You can at least find 10.2 over 11, put this answer in here. Forget meters per second. Find your answer, put it here. Use your calculators to help you. Remember this line, if I put the dashed line like this, it's Taksim, yeah? 10.2, Taksim 11, divide 11. Hopefully that's clear. So just as a summary, we've got two equations for collisions. Inelastic, where we do this formula. Now remember to use the right formula. You have to find the masses, which are the kg numbers, find the speeds, and you're looking for the final speed after the collision. After, right? The after is always on the right. The before is always the numbers on the left. And then what from last week we had our elastic formula, which is this one. Slightly different on the right, see? We have two separate objects on the right, so we have to find two momentums, two mass times velocities. After the collision in inelastic, we only have one because the fish ate the other fish. So we only have one mass times velocity. But we have to add the two masses because, of course, now if this is 1 kg and this is half a kg, if this is on top, okay, we have 1.5 kg. So the new mass after collision is 1.5. We plus them for the where they collide and they stick together. Try question 2. There's no special conversions. You have the speed, you have the two masses here. Look, it says here the initial velocity is 0 for this one. So here's before and here's after here. Trying to find that final speed again, just like this problem. So solve it the same way. Use the same method. Alright, what did we learn in these two lessons? Well, we learned how to calculate final speed after collision, right? Just gonna say, remember, speed is like velocity, but velocity has direction. You didn't really learn that today, but I wanted to make a clear point. After a collision. We focused on inelastic collisions. The fish is the inelastic collision. But remember, when they don't stick together, it's elastic. That was last week. Just write something you're enjoying there. We move on to the last two lessons. Remember, you can pause the video anytime, just if you're doing this live, just to catch up with the notes, rewind it, make sure you understand the problems as we do them. Okay, let's check out these last couple of pages before we move to the assessment then. This is, remember, we're on week 5 now. So week 5. It looks like we've just got more problems with the same equation here, because this is the pop quiz, so checking what we learned last lesson. We're going to apply the law of conservation of momentum. Remember that law, it's like a formula. It's the two formulas we've just been talking about for elastic and for inelastic hitting. Elastic, inelastic. All right? Let's check it out. Consider a 10 kilogram fish that swims towards a 2 kilogram fish. The larger fish swims at 1 meters per second and the smaller fish is at rest At rest, remember 0 meters per second. So we can say this one is 0 equals our V2. And let's call the bigger fish number 1, so this can be M1. A smaller fish, M2. So the smaller fish and the smaller fish speed initially. So M2 and V2. And here's M1, and it says the bigger fish is at 1 meters per second. So this is V1. So I've told you what is what. Put it into the equation. Put those numbers in the equation. See if you can use the method that we learned here. It's the same problem but with different numbers, okay? So use the same method as task 3. We're putting just the numbers into this formula and solving for this V. Don't call it V2, just call it V. Because it should be V. It should really be V3. It's not the same as this one, is it? This one is 0 always for the questions we've done so far. It doesn't have to be. Maybe the other fish is moving too. But this is our V defined. Alright, so I'll let you complete that. I've sort of given you the numbers at least, how they relate to the letters, so you should be able to put it in the formula. Find the final velocity V. And it looks like these are similar problems, so we're just doing more examples. We've got 2 problems here to solve. We're still finding the final velocity. We're still finding V, so it's the same method. Determine the final velocity. Afterwards, we're finding V there. Same again, find V after. Now look, they're stuck together here, so this is inelastic, right? So use the inelastic formula that we're talking about this week, week 5. Inelastic. Same again here. They're just using different numbers. So for question 2 there, we're always using our formula. Let me find it. This one. Okay, let's check question 1 then. Is that the same? Is it asking us, yeah, determine the final speed, the post-collision speed. Post means after, so after collision speed. So this is all the same stuff, guys. There's nothing new here. We just apply this method, this formula. I'll do one more example, so I'm going to do question 1 with you, and you can do question 2 yourselves, all right? Let's look at it then. I'm going to write the formula out. M1 times V1 this is going to be a better version of the formula, better for your calculators, plus M2 times V2 equals M1 plus M2 times, now this is V3 really, and it always asks for V3. Always try and find V3 or V. I'm just going to call it V, doesn't matter. The point is it's not the same as V2, so we shouldn't call it V2. Alright, so let's look at the numbers in the question. We've got a brick and a cart. It says they're combined, so it's inelastic. Doesn't matter which one is which, so let's call the brick object 1. 2.1. It says it's placed on top of the cart. It's placed gently on top. So the brick to begin with has no speed. Not in the horizontal direction. Imagine here's my cart moving, and I just gently place a mass on top of it. So the mass is increased of the total system after the collision. That's why we have to do this one plus this one, because now I have the mass of the calculator plus the mass of the dice. Or in this case, the brick, here's the brick, and here's the cart, right? So the mass is increased for after the collision, but we only have one object, so we only just do one mass, the total mass times the velocity. Right, let's try and find the mass of this next thing. So we have a cart here. Well, is it 26 or 2.9? Those are the other two numbers. It's the mass of the cart. There's my brick. Now the cart numbers before the collision, look, kg, that stands for mass. So remember that's going to be 2.9. And my speed is here, 26 centimeters per second. We can leave it in centimeters per second, doesn't matter. It doesn't say we have to give our answers in meters per second. We just have to remember it. When we give our answer, it will be cm-s, centimeters per second. It's quite slow. Centimeters aren't very far, are they? Now add those two masses together. Which are the two masses again? kg, kg. 2.1 plus 2.9. And we times that by v, we don't know v. So now again, remember, we just split up the long equation into steps. If you can do it all together, great, but you'll probably make an error. Let's just break it down. Find these three numbers. Times by v. So still need the plus, still need the equals, still going to times by v. 2.1 times 0 is 0, remember, about 0. How many zeros, how many 2.1s are there if you have 0 of them? Well, there's 0. 2.9 times 26. That's going to need a calculator. 75.4. Can't see my point there. Make sure you always put your point in if you've got one. That's better. And the last one, 2.1 plus 2.9, that's going to be 5. Don't need a calculator for that. So 0 plus 75.4 is 75.4, so I don't have to add anything. Equals 5 times v. Now those two are timesing. I want just v, I don't want 5v. So if 75 is 5v, if I divide 75 by 5, I'll take v. So let's get my final step. 75.4 taksim 5 equals 15.08. Now to three significant figures, that's 15.1. So round it always to three numbers there. And what's the units for? Speed. Meters per second. There's my answer. Done. Full example, guys. Do the same for this one. Do the same for this one. But this one, you don't even have the sentence. It just gives you the diagram straight away, so it's much easier. Before, here's M1, V1. Here's M2, V2. Here's M1, M2, V3, yeah? V. Before and after. Think about it. Practice those. Have a go. What did we learn though? Well, really, we were just practicing the same thing. I don't think there was much new today. If anything, one thing that was a little bit strange about that question, my text not working. If something has vertical speed, it does not count towards the horizontal collision. Because the brick was moving down, right? It still had speed, but it was moving down when it collided. These collisions are in one dimension that we analyze. So we consider this way, how much it's moving this way only. Well, not moving that way at all, it was only moving down until after the collision, when the cart picks it up. So if something has vertical speed, it does not count as the horizontal speed in the calculation. As the horizontal does not count towards the horizontal collision momentum sum. We also did more practice on inelastic when we lose energy. Remember, inelastic when they stick together, collisions. All right, I think that's all for today, guys. Stay safe, stay healthy. Remember, the assessment and the other video as well, if you didn't do the other questions, is all on the shared folder. The links are there to the YouTube channel. I also post these videos on your WhatsApp group as and when they go up. When you're ready, you can try the assessment. That's going to be in week 6. Just upload it to the classroom for me to mark. And good luck, guys. Ma salam.